just showed you how that in a measurement with this paper clip, you are to include every certain digit that the instrument allows you to read. So we have 2.3, and then the mark is between the 0.3 and the 0.4. And we just showed in class how that each individual would read that differently. I would read that as 2.3, and to me it's sort of right in the middle, 5. I would read that 2.35. Doesn't make me any more right or wrong than what you wrote down on your papers. All right? So that leads us into this discussion. How do you think scientists can ensure or measure that their numbers are accurate and precise? Okay? The terms we're going to talk about. The first term is accuracy, and that's in your book on page 64. Accuracy is how close a measurement is to the true value. The true value. Yeah, that's on video. If we were throwing darts, and I did that because of this, on your test you're going to have an essay. That essay is to use an analogy to describe or compare accuracy and precision. And so accuracy would be throwing the darts and hitting the bullseye, hitting the right target, hitting what we aim at, getting the right answer. How close to the right answer? Okay? Of density of water did we get? That is accuracy. All right? The other term is standard deviation. Precision. How close a set of measurements are to each other. So in other words, I throw the darts, and I never hit the bullseye. But I hit the same little square on the dartboard every time, and they're all grouped together. So in that case, I'm very precise with my hands, but I'm not accurate. Or I could, like, if we really had a dartboard in here, I could throw those darts and hit the bullseye, all of them in the bullseye, probably 8 out of 10 times. Coach Camus could. And so you would say he's both accurate or precise. For example, if I take any basketball players down here, we go shoot free throws. One basketball player over here, their free throw is probably going to be 5 out of 10, so their accuracy is 50%. Another basketball player may be 6 out of 10. Coach Camus shoots him, it's probably going to be 9 out of 10. I'm going to shoot 90% because I'm accurate. Okay? Now the 5 out of 10, the 5 out of 10 basketball player, their free throws, the other 5 shots that they missed may hit the same side of the backboard and nothing else. So then they would be, not very accurate, but pretty precise. Okay, so you can be accurate and not precise. You can be accurate and precise, and you can be precise and not accurate. And so the definitions are accuracy, how close a measurement is to the true value. Precision is how close a set of measurements are to each other. For example, everybody in this class could have found the density of water to be 0.563. The true value is 0.997 at 22 degrees Celsius. So even though we were far away from the right density of water, everybody in the class got the same measurement. So that means that our numbers in the lab are precise, our instruments are precise. We've just messed something up. Okay? All right. And so how do you measure accuracy? And we've already did several examples of this. You measure accuracy by the percent error. So the percent error is a measurement of how accurate your numbers are. So percent error is a measurement that indicates the accuracy of a number. Okay? And so we've talked of how that is the true measure minus the experimental measure divided by the true times 100. Does anybody see a difference in the formula I have here on the board and the formula on your lab sheets? Huh? Observed value would relate to which one up here, true or experimental? Experimental. So on your lab sheets, the observed was what? First. So now we go back to what me and Redskin fan back here was talking about. And that is, does it matter if my number's first and I subtract the right answer, or the right answer's first and I subtract my number? Does it matter?
No.
Why does it not matter? It can absolutely matter. So in other words, it's the difference of the two numbers, or as your book explains on page 65, it is the error. Just the error. Take the two numbers, subtract them, make them positive if it's negative. Okay? So you take the error of your numbers and divide it by the right answer times 100. This is how we can make an analogy of that. You get 8 out of 10 questions right on the quiz. Already in your head right now, you've calculated your percent because that's how we've trained you. Okay? But forget that. You got 8 out of 10 right on your quiz. How many did you get wrong? 2. How'd you find it? 10 minus 8, right? Yeah, 10 minus 8 is 2. So to find your percent wrong, not your percent right, don't take 80 from 100. You take, to find your percent wrong, we would take the 2, the error, the 2 divided by 10 times 100, which would be 20%. So you've got those to do tonight. You got one or so of those to do tonight for homework. So percent error, okay, is the measurement of the accuracy.